for the recording. So the folks who are not with us miss out. Believe it or not, there is at least one person in this class who's actually never been in class with us because she lives in Japan and it's the middle of the night there. So I'm going to say hello to that student, and I know there's others who are geographically isolated. Farhan, of course, good evening. I know it's what, 10:30 at night there, something like that. Yeah, it's like, yeah, I'm tired, but I'm here. So
11:30 actually.
is it what?
11:30.
11:30, my bad, even worse. Time change. So I made a deal with you at the beginning of class last time, just to reiterate. Um, Evaluations. There are two different evaluations that I'm going to ask you to do. One of them is the standard Iowa course evaluation that asks lots of generic questions, and they are not terribly helpful questions, but they are necessary, and those are the kinds of things that we use for evaluation purposes on our end. And so I want to motivate you guys to complete that. I made a deal that there are 23 of you, and if at least 21 of you complete that evaluation, everybody gets a point of extra credit. So, to give you an update on where we stand on that, the other class is currently beating you. Can you see this? So, 11 out of 23 of you have done it so far, 15 out of 25 out of the other class. So, you can't let this stand. Right? We got to have some 6242 pride and show the SEM kids who's boss. So everybody gets a point of extra credit if we get at least 21 out of you guys and 23 out of them. And then the other evaluation, you should have gotten an email from Qualtrics. It's a customized survey that I set up that has questions that are directly relevant to your experience with different aspects of this class. And in that, each of you who completes that survey will get a second point of extra credit. And so I can tell which email addresses have completed surveys, but I do not have the responses linked to the email. So it is still somewhat anonymous. I do want you to feel able to provide whatever commentary you feel is truthful and helpful. Right. So even if it's criticism, I welcome it in the spirit of trying to make this experience better. So those are my deals. Any questions on my deals? All right, so homework 5 is due this evening. Any questions on homework 5 for those of you who are still plugging away? I have office hours as usual, so that's another option for you. Um, then we have, let's see, the next thing that you'll get to do is formative assessment number 6, which I had a question about already. It is a different animal. We're going to go over today the things that that's based on, but I want you to give it a try. So I'm asking you to write equations and to write code based on a particular example of a model. We are going to go over it. So if you look at it and you're like, oh my God, I have no idea how to do any of this, that's okay. We're going to go over it. But I wanted you to give it a try. So low stakes, you get your points just for giving it a try. And homework 6 then has a direct analog of example 6, which we may get a chance to start today, but it may be next week. And then that's not due until the end of finals week. So you could be done with this class as soon as you want to be. Everything is out there and should be able to be wrapped up. So any questions on any of that? All right, then let us dig back in to the world of moderation. So we started talking about, this is lecture 6, I'm on slide 8. This type of model, where the new term there that's in the green box refers to something that's called an interaction term. And the idea of an interaction term is that it conditions the effect of a predictor variable to be specific to one's value on another predictor. So the answer to a question of, well, does X matter in predictor Y and predicting outcome Y? The answer would be it depends. It depends on your score on Z, how much X matters. And likewise, does Z matter? Well, it depends on your score on X. So this type of model is used very frequently to address questions about why some things matter more for certain kinds of people. The idea of moderation, and this is a particular form of moderation which hypothesizes that we have a linear relationship that varies linearly as a function of another predictor. As you might imagine, there's all kinds of nonlinear types of these that you can specify as well if that's going to be more appropriate, but this is a good place to start. So we talked about vocabulary. We went through this slide 11 last time, and ways of thinking about what a slope represents conceptually and who it applies to. So a taxonomy that I thought might be useful in describing these things, the three choices that are right here. A slope can represent a bivariate marginal effect, a unique marginal effect, or a unique conditional effect. So bivariate versus marginal, or excuse me, bivariate versus unique. That dimension refers to whether or not you're looking at the effect of a predictor all by itself or the effect of a predictor after controlling for other variables. So the unique part is what does that predictor contribute that none of the other predictors contribute to the outcome? If it's bivariate, it's just how does it contribute at all? So there's none of the unique partialing. So for instance, in this model right here, by the way, special cases of this that I've highlighted right here, when you only have one predictor, if that predictor is a quantitative variable, do you remember what this is called? Anova, not this one. Anova is going to be down the page. If I have a Pearson R, yes, it is. This does give you the same thing as a Pearson R. In terms of what one might call this, a single quantitative predictor of a single quantitative outcome is called a simple linear regression. Simple as opposed to multiple linear regression, which is what it's called once you get more than one predictor in the model. If this W variable were a binary variable instead, what's the special name for that combination? It's a t-test. Yeah, it's either a two-sample or independent groups t-test is what that's called. So I'm telling you these things because you may see these words used by other people, and I want you to be familiar with the different ways that people talk about the same thing. Synonyms run rampant all through quantitative methodology. If I were to have two predictors in a model, and they're both quantitative predictors, that would be a multiple linear regression as opposed to a simple. If W and X were dummy codes that distinguished groups, like if we had 4 golf groups, for instance, or 3 fear groups, then what is that combination called? Starts with an A. We'll play hangman. Yeah, Anova, analysis of variance. So if you have a grouping variable as a predictor, that's analysis of variance. If you had 2 grouping variables at the same time, that's two-way analysis of variance. If you had 3, that would be three-way. And those models presuppose that your grouping variables are allowed to have interaction terms, which is what we're talking about. And last but not least, if you had some combination of a quantitative predictor, which would be called a covariate, along with one or more grouping variables, then that is Anova. So analysis of covariance is what it's called. To me, these are all one thing because what they have in common is that they're predicting a quantitative outcome where after you're done predicting it, the E residuals at the end of the model here, they should be normal, independent, and have constant variance. So this whole thing to me is just one model. It's a GLM, general linear model. So then we looked at unique marginal versus unique conditional. So for instance, W, That's a marginal effect because the predictor W, its effect in the model is described only by beta 1. So the effect of W is the same for everybody. Beta 1 describes the change in Y for a 1-unit change in that W predictor across the board, marginally. In contrast, X and Z are conditional because neither of them stands alone to describe the total effect of their predictor. Beta 2, the slope that goes with X, in this context in which X is also involved in an interaction, beta 2 gets called a simple main effect or a simple slope. Again, with the name simple, I'm sorry, that's just what it's called. I'm going to go with conditional because I don't wish to piss off my audience by implying something is obvious or easy. All right, there's too many journal articles where you see clearly or obviously, not a good way to reach out to your audience. So we'll go with conditional. So the effect of X is only going to be given by just beta 2 if Z is 0. If Z is 0, this last term drops and the effect of X is given just by beta 2. So what it's going to end up happening is that beta 2 describes the effect of X particularly when Z is 0, conditionally. The effect of what X would be is going to be different for somebody with a different Z value. And the exact same thing is true in the main effect of Z. It becomes a conditional main effect specifically when X, the other interacting variable, is 0. So these things allow the effect of these variables to change as a function of each other. So I know that having letters makes this very abstract. Would you like to have a real life example? Would that help? Okay, Solomon, I'm calling on you, bud. He sent me an email the other day and I said, oh, can I use this in class? Okay, do you have, can you talk, Solomon, or type? Tell them what you asked me.
Yes, all right. I'm
Okay,
here.
hit me.
Okay, so predicting course grade based on a student's webcam time on in the course,
Mhm.
moderated by the number of students in the class course.
Okay, so you're predicting course grade from the amount of time someone has their webcam on.
Yes.
Yes, that's what to start with. Do you think that having your webcam on helps your course grade?
No. Potentially, but no, probably not.
I'll say clearly, right? Because there is no webcam, right? You couldn't I'm not going to let that one go. So you don't think it matters. But could it matter sometimes and not others?
Right, yes.
So if you have class size, do you think that being in a larger class makes you more likely to have a good grade versus a bad grade?
In this case, the larger class, I would think there would be no connection.
There'd be no connection. So class size doesn't matter, but it
Right.
does matter in the sense of making it more important to turn your webcam on in some kinds of classes?
In a smaller class,
In a
yes.
smaller class. Okay. So yeah, this is exactly the situation that we're talking about. Where does putting your webcam on matter? The answer is it depends. It may matter a lot, meaning more webcam time relates to a higher course grade if you're in a small course in which presumably your grade is based on discussion and participation and stuff like that. But if you're in a large class, like if there's 300 little boxes, maybe having your webcam on doesn't matter so much. So that's a great real life example of what we're talking about, moderation. And yes, we would have to have covariates in here as Tamar suggests. W would be like the number of children screaming in the background, or babies crying, or pets climbing over your desk, or things like that that might relate to webcam use, potentially. Do any of you have other ideas from your research or your lives you can think of that typify moderation? No, not so much. No, another one I can think of is from a friend of mine's dissertation. She was interested in studying the link between stress responses and disease responses. And she was a clinical psychologist. Her husband is a dermatologist. And so she actually got permission to do her dissertation work with his clinic patients, people who had the disease psoriasis. So, psoriasis is a skin condition that's thought to be susceptible to changes in experience, stress, and stuff like that. Stress is generally bad for you, right? So, if we subscribe to the notion that stress is bad for you, right? Stress makes your disease condition worse. Is that going to be true for everybody? Or is there anything you can do about it? So, several of you are in counseling type programs, right? Like the point of your training is to describe how to intervene, right? To help people deal with stresses or life events or things in a better way, right? So the whole premise is like, no, stress doesn't have to be bad for you. And so her dissertation was looking at coping strategies as moderators of the effects of stress. And in particular, she was interested in the role of forgiveness. If people who are more forgiving, do they show a reduced effect of stress in predicting disease severity? That was her dissertation, and it turns out they do. She did find that relationship. So that idea of protective factors, things that make the effect of a bad predictor less bad, or risk factors, things that make the effect of a bad predictor more bad, those are the ideas of moderation. That's what we're talking about here. So you'll see a lot of these once you start looking in the literature, questions that describe these sorts of how do we dampen the effect of a predictor, or how do we make the effect of a predictor stronger? Moderation. Okay, with me so far? Yeah? Okay. None of you looks happy right now, but I'm going to try not to take it personally because it's week 16 of the semester or whatever, and I know. But do you want to play with some numbers? Do numbers make you happier? Some of you. Numbers make me happy because numbers are like they are what they are. You know, you don't have to worry about the number being good enough or the right number. Like it is what it is, and there's a comfort to that sometimes. So let me teach you how to interpret. Farhan's like, yes, I love numbers. Numbers are my friends. Let me make you make friends with this, because this is, once you get it down, you've got it. And I have, I think, figured out a way to make this as simple as possible. There are only 4 kinds of interactions patterns in the world, and your job is to find which kind it is. Here is the key. An interaction takes the main effect of a predictor and makes it either more positive, less positive, more negative, or less negative as a function of the interacting predictor. Your job is just to recognize which of the 4 patterns you're in, and then you'll know how to talk about it. So we can practice. So here's my equation. We're focusing on the last 3 here. I'll try and make this a little bit bigger. And so here are my coefficients, different combinations for these different effects. So I'll do the first one with you. So the slope of x is 10 in this first line. The slope of z is 5, and the interaction term is 2. So there are 2 different ways to talk about this x by z interaction. We can talk about it as how the interaction term makes the x slope different as a function of z. That's the first column here. Or we can talk about it as how the interaction makes the z slope different as a function of x. So if we do the first one here, what this model is saying is that the x slope is 10, specifically when z is 0. The interaction slope is going to make that 10 more positive as a function of z. So I have an effect that's 10. If it's paired with a positive interaction term, then for every unit change in z, that slope of 10 is going to become more positive by 2. So z is enhancing the effect of x in this case. It's making it stronger. Because both of the main effects, these two cells here are in the same direction, the type of relationship would be the same no matter which way you talk about it. So these are both more positives. Now if I do these two, 10, let me see here, is the slope of x, and the interaction is 2. Those two are the same. But if I have -5 as the slope of z, what does the 2 do to it? So if the effect that I'm interested in is right here, the -5, the interaction term that's positive is going to work against it. It's going to make it less negative. So if I have a slope that's -5 paired with positive interaction of 2, for every unit higher the other variable is, that slope becomes less negative. So for a 1 unit difference, it would go from -5 to -3, and then it would go from -3 to -1, and so on. So this is a reduction of a relationship, a dampening effect. What if I have, this is my slope, -10, paired with a positive interaction? That's the same, less negative. A 5 and a 2, that's a more positive. We already did that one. Two main effects that are negative paired with a positive interaction term. Those are two less negatives. Here's a new one. If I have a 10, that's my slope, and the interaction term is -2, what is my -2 interaction doing to my positive 10 slope? We have a vote for more negative. But is 10 a negative number? The slope is 10. The interaction is modifying it.
Less positive?
Yep, this is a less positive.
Hey, Lisa, really quick question back on -10, -5. Why wouldn't that be more negative?
It would be. I messed that one up. Hang on. Thank you for catching that.
Okay.
Actually, no, it's this one. Nope, I was right,
Yeah.
because this is my interaction term.
So -10 and -5?
-10 and -5 are each the individual slopes that the interaction term is moderating. The interaction term, though, is the positive number.
Is the positive number, so that's 2. So less negative on both. Okay, roger that.
Yep, yes, thank you for clarifying. So each of these, the first two columns are the potential slopes to be moderated. How they are being moderated is given by the third column. So let me make sure that all of these are right again. So if these are both positive, a positive moderator is going to make them both more positive. That line's okay. This is a more positive. This is a less negative because we start out with a -5 and a 2 works against it. We start out with a -10, a 2 works against it. That's a less negative. 5 and 2 is a more positive. These are both less negatives. And then, yeah, this is the first one that we've seen. If I have a 10 paired with a negative interaction term, the role of the interaction term is to make the 10 less positive. So the interpretation would be X is good for you. It's less good for you if you're high on Z. Less good for you is maybe not what I would put in a paper. I would have to get out my GRE vocabulary that has gone unused for most of my life and have to come up with a synonym for what less good for you. Like it's still good for you, but it's less good for you. I would say that Z dampens the benefits. Z reduces the benefits, something like that. The ones that are do we have a more negative yet? Or do we have a more negative yet? We'll wait for that one. These are both less positive. This one's still a less positive. Now this one. If I have a -5 as the slope that I'm talking about, what is the -2 moderator going to do to it? This is a more negative, yeah. Yeah, I need to type correctly. That would help. More negative. So what does it mean conceptually to have a slope that's more negative? Well, if you have an outcome that's a good thing, then having a negative slope means X is bad for you. Having a moderator that makes it more negative means that X is even more badder for you if you have high Z. So high Z exacerbates the problems of X. There's a good one. It amplifies the damage caused by X. More badder for you. So the point of this is that you can't just look at the sign of an interaction term and know what it's doing. If I have a positive interaction term, that can either take a positive slope and make it more positive, which is a strengthening of its effect, or if I have a positive interaction term paired with a negative slope, that is going to make it less negative, which translates into a weaker dampening effect. If I have a negative interaction term, that can either make a positive slope less positive, or it can take a negative slope and make it more negative. So it's which of the four combinations are you in, then you'll know how to talk about the pattern of moderation. Is it a strengthening effect? A strengthening effect would be a more positive or a more negative. A dampening effect would be a less positive or a less negative. Okay, how we doing? Okay, so let me talk about centering then. Another activity for us. So earlier in the semester, we talked about the idea of centering. Centering is subtracting or adding a constant to relocate the scale of a predictor so that 0 means something, right? So like in homework 5, I asked you to center motivation at 4 because that was near the middle of the scale, to center GRE scores at 500 and 550 for the same reason. And if you do that, the only thing that changes is the intercept up until this point, because the intercept is always the expected outcome when your predictors are 0, and so it will move around if 0 means something else. But now, in this context of moderation, centering is going to change the slopes of your predictors as well as the intercept. So let me demonstrate with a little story here. Let's say that Y is student GPA. X is parents' attitudes about the importance of education, measured on a 1 to 5 Likert scale. By the way, it is Likert, not Likert. One of those things you can say wrong and have people giggle at you. It's Likert. And Z is parents' education level, measured in years of schooling. So if I were to look at the moderation effects of education on attitudes or vice versa, I might be tempted to fit a model that looks like this. And let's say that these are the coefficients that I got back on my output. So beta 0, that's my fixed intercept, right? The UR here sign of my model. So 30 is the expected GPA for what kind of student? So these predictors are uncentered. They are in their original scales of 1 to 5 or years of education. Yeah, it's when the other variables are 0. So when ed equals 0, I'll put in parentheses, what? Because that can't happen on a scale of 1 to 5. Or excuse me, I want to do attitudes first, because actually that can happen. And education equals 0, which means no school at all. Now, what are the odds that I have data collected from someone who's never been to school? Not so good. So 30 is a value that is probably well outside the range of the data. Let's go for beta 1. The coefficient for beta 1 is 1 in this example. So all slope interpretations start out the same way. The slope is the change in y, so the change in GPA, when, or let's say for, a 1-unit change in attitudes. That's what I would normally say. Is that the end of my sentence, or do I need to keep typing? We got to vote for each. So is this a marginal effect, or is it a conditional effect? I see everyone squinting at their screen, so let me try and blow this up. Yeah, this is conditional because of the interaction term. So this slope of 1 holds only for a certain kind of person according to this model. It only holds for people with education equals 0 because that is when this last term would zero out. So beta 1 describes the effect of education amongst people who've never been to school. Not wrong, but weird. Likewise, beta 2, change in GPA for 1 unit change in ed for also conditional. I got to finish it off for attitudes equals 0. That can't happen. So beta 2 is describing an impossible effect. So far, we are 0 for 3 in parameters that actually mean something. They're all referring to impossibilities relative to the data that we've collected. The moderator, though, 0.5, that one's okay. 0.5 describes how the effect of education changes by attitudes, or the effect of attitudes changes by education. So if we start with the first one, change in ed slope per unit at. And I'll finish out the second one, change in at slope per unit ed. So I want to make a point about the difference in how these interpretations start. When you're talking about the main effect of a predictor, you're talking about the change in the predicted outcome as a function of that predictor. When you're talking about the effect of a two-way interaction term, the job of the two-way interaction term is to operate on the main effects, which then operate on the outcome. You've heard of trickle-down economics from the 1980s. Some of you weren't alive in the 1980s, but some of us were. This is like trickle-down statistics. I have a two-way interaction term that changes my main effects, and then my main effects change my y. And given the coefficients here are all positive, what the interaction term is doing is taking the slope of education and making it stronger by 0.5 for every unit change in attitudes. And that's also taking the slope of attitudes and making it stronger by 0.5 for every unit education. So I can come up with the predicted GPA for any kind of person based on my model, and by filling in coefficients for somebody, say, who has a mid-level attitude of 3 on my 1 to 5 scale and a high school education, I could get a predicted GPA doing the math here, or using a LINCOM or an estimate statement in software to do this for you. So I could come up with the predicted GPA for a person from my data set of 75. Okay,
Lisa, I have a quick question.
yeah.
So you can still figure out predicted GPA even though like our beta 0 is non-existent.
Mm-hmm.
Like it doesn't make sense.
Mm-hmm. Yeah, so if
Is-
it, yeah,
Yeah,
go ahead.
doesn't that problematize the whole thing though? Like I feel like if my beta 0 can't function in real life, then how can I even start?
So, great question. The answer is whether or not you would consider this model wrong or just weird. The fact that these 3 of these 4 values refer to people who don't exist in my data or can't exist is not wrong, because yeah, the model still works regardless of where your reference point is, but it does make it weird. And so you're right that you can still figure out what GPA is for any kind of person. So the model still works. If I were to center these variables differently, I would still get the same R square, I would still get the same predicted values, and everything mathematically is still okay. Where we start to run into problems is actually with the beta 1 and the beta 2. Because this is a very common mistake that people make in looking at these models, is to forget the conditional part out here. So if I looked at this and let's say that the slope of attitudes was non-significant. Let's say that that estimate of 1 was not different enough from 0, p greater than 0.05. Does that mean that attitudes don't matter in predicting student outcomes? Because that's what you'd want to say, right? Like if you just look at this on the surface, you'd be like, well, the effect of attitudes is non-significant and therefore attitudes don't matter. But no, they don't matter for a particular kind of person who has never gone to school. That's what that number means. And likewise, the slope of education. That slope, being significant or not, doesn't really tell us very much, because that slope is particular to attitudes equals 0, which isn't even possible. So the answer to your question, Maria, is both it is okay and it's not okay. It is okay mathematically because you can still get predicted values for any kind of person. The equations work out if you put in values that are different than 0 to give you things that are okay. But it's not okay in the sense that people are going to be very susceptible to misinterpreting what this is telling them because of the conditionality.
Okay, that really makes a lot more sense. Thank you so much.
Thanks for the question. So centering will fix it. And being able to fully describe how the model works in terms of moderation requires not only figuring out how to talk about the two slopes that you get out of the model, but also how to ask for any other slopes that you might want. So this is simple slopes, as they call it, and I'm sorry for that terminology, but this is what I want you to practice on your formative assessment for next week, and what I want to help you get used to doing here. So I fixed it. Here's the same model with centering, attitudes at 3, and education at 12. And here is what the new results would look like. So now, my intercept of 75 is my expected GPA for what kind of person?
Attitude at 3 and education at 12.
Yeah. And this, by the way, in your homework, this is why I ask for the fixed intercept and it has the word check next to it. Because the only way you can get the right intercept is if you have centered your variables at the right places. That's why I ask. So this kind of person could happen in our sample. That's possible to have someone with mid-range attitudes and a high school education. Likewise, beta 1, it used to be 1 and now it's 7. The slope still refers to the change in GPA for 1 unit at when. Now what kind of person is this for? Yeah. So attitudes does matter. That slope is particular to when this last term would drop, and that would only happen if education equals 12. So it's not the other slope, it's the value of the other predictor that goes to 0. Beta 2 used to be 2, now it's 3.5. And that's because it's the change in education now, not for attitude equals 0, but attitude equals 3. And the interaction term is exactly the same because it's unconditional. It does not depend on centering. It's marginal.
Lisa, would you just describe beta 1 one more time?
Sure. So 7, that's my coefficient. That is the change in the expected outcome of GPA for a 1 unit change in attitudes. But the end of the sentence is the part that we're focusing on here that's necessary to make it conditional. And that's because if we look throughout this equation, we see that attitude variable in 2 different places. So beta 1 is not the only thing that describes the effect of attitudes. Beta 4 or beta 3 also does. So the only situation in which this 7 is it, in terms of what goes into that effect, is if this last term drops. And that will only happen if education is 12 and the pink goes to 0, which makes the rest of this drop out too. And the same thing happens in talking about the education slope. The only situation in which that 3.5 is all that we need to know to describe the slope of education is if the interaction term drops. And that only happens if attitudes equals 3. So each of these, what are known as conditional main effects, the slope of a variable by itself is specifically when the variables it interacts with are 0. The other one. So how did I know what these new values were going to become? I want to teach you the logic by which you can figure out what the model says the slope of the predictor would be at any value of the interacting predictor, not just the ones that happen to be the 0 in the model, but at any of them. Because you might have a hypothesis that says something like the effect of education only matters in people who have attitudes that education is important. You might have a hypothesis that the effect of education doesn't matter if you don't think it's important. So you might want to know, what does the education slope look like for people who have a score of 1 versus people who have a score of 5? And you can ask the software to estimate what the education slope would be at any level of the attitudes variable. Do you want to see how? Why not? So practice writing the code that would do predictions for you. So one of the things that you might want to find out is what the model predicts the outcome to be. And these are the types of statements that you can use to figure that out. You've worked with these before, generating predicted outcomes. The only catch is making sure that you have the interaction term included in the prediction. So I've got estimate statements here, or LINCOM statements here, for 3 different types of people. I have helped you out into what they would look like by including the intercept in each, because if we're trying to predict the outcome, we need the whole model involved. Everything goes into the model, including the intercept. So to fill in this equation for what GPA would be, I need 1 beta 0, and that's why I have the 1 here and the 1 down here. If I want to figure out what y hat would be, the predicted GPA for somebody with an attitude of 5, what goes here? There we go. Attitude is centered at 3. Yeah, this is a finger question. Yeah, 5 is 2 more than 3. Likewise, if I want a prediction for somebody with education equals 16, what goes here? 4. Now, last question, don't think too hard. What goes here? Attitudes times education. Yeah, still a finger question. You just got to work a little harder. Yeah, 8, because 2 times 4 is 8. Do you remember at the very beginning of the semester when I said statistics doesn't involve math, it involves logic? This is what I meant. No matter how bad at math you think you might be, I am confident that all of you can do 2 times 4 equals 8. And that is all that it takes to conquer and estimate moderation models. What goes here if attitudes equals 1? Yep. Tricky hand signals. -2. What goes here if attitudes equals 12? What goes here? Don't think too hard. Yeah, anything times 0 is 0. So you will get a chance to practice these sorts of statements on homework 6, and this is all I'm asking you for. Generate predicted outcomes by filling in the values of the predictors. The one way that you'll screw this up is by forgetting where they're centered. So it's relative to the centered value. That's what these coefficients need to be. Okay. Now the new part. Figuring out how to do the same thing, but for slopes. To estimate what the slope would be at particular values of the predictors. So this model right here gives me two slopes. It gives me the attitude slope when education is 12, because that's where it zeroes out. And it gives me the education slope when attitudes is 3. But what if I wanted the education slope when attitudes is 5? Or 1? Or 6.7, right? I could pick whatever I want. Well, the way that I learned how to do that back in the day was to recenter the model. Well, if I wanted to know what the education slope would be for 5, then I just recenter attitudes at 5 and I rerun it. And I didn't learn until much later that you don't have to rerun the model with a new centering strategy. You can just ask for it. And so I want to teach you how to ask for it. So there are 3 steps to figuring this out. In the model equation, you figure out all of the terms that have the predictor in common whose slope you're interested in. You then factor out that common variable, and then the formula for the slope is provided. And by calculate, I mean get the program to do this for you. So here's what it would look like. Make this a little bit bigger. Or not. So first one. Let's say that we want to get the attitude slope. Step 1 in the process is scan through the equation, find all the places that have attitudes in it and bring them down. Okay? So the slope that we're getting for attitudes is going to be a combination of beta 1 and the interaction term because attitudes is in there. Likewise, we're going to get the education slope by pulling down education by itself and the interaction term. So note what's not in these new equations. And by write the equation for the slope in formative assessment number 6, this is what I mean. To get the attitude slope, beta 0 is not there. Okay, beta 0 does not go into these equations for slopes because beta 0 is an intercept. Likewise, if I am trying to get the attitude slope, only terms that have attitudes go in this line. Education by itself is not relevant. And only education goes into the second line. Okay, with me so far? Then we factor them out. Pull the common term out and stick it behind. So if I factor it out is, I think, the math term. I think of it like a vacuum, like you just like suck it out and just stick it behind, right? So then you're left with beta 1 plus beta 3 times the interacting moderator. So that term in brackets, that is your slope of attitudes. That term in brackets is what has to multiply your value for the predictor in order to create your predicted outcome. So itself, it is a linear combination. So the attitude slope of beta 1, I think this little equation right here makes it easier to see why beta 1 refers to the slope of attitudes, particularly conditionally when education is 0, because that's when the second part drops. And likewise, beta 2 is the slope of education, specifically when attitudes is 3, because that's when this little part drops. And if you wanted to calculate stuff by hand, here's how you would get the standard errors that go with them. Am I going to require anyone ever calculate standard errors by hand? No. The computer will do it better and faster and with more level of precision than any person ever will. So let's make the computer do it for us. I need to exit out of that so I can start typing again. Okay. Here's my model, same model that we have. And I have the two slopes that we just figured out on the top of the page here. So help me fill in my values, because this is different than what we did before. We're not predicting the outcome, okay? So the only things that go in this line are the terms that relate to the quantity we're trying to predict. So what we're trying to predict is attitude slope. Here's the equation that this line is going to represent. So there's no beta 0 in that little equation. So that's why we have intercept 0. Now what goes here? If this is the thing that I'm trying to recreate. 1. Yeah. So the word attitude refers to beta 1. That is what it is referring to, is the estimated slope. And so I need one of them. Oh, that was not effective. Come back down here.
Can you repeat that one more time?
Yep. This little equation right here, that's what we're trying to get the code to give us. So where I just typed a 1, it's 1 because what I'm asking for is the attitude's slope. And to build that slope, I need 1 of the beta 1s. Does that help?
Then would you need 1 for all of them?
No.
Okay. So I think it's going to make sense in a second then.
Okay. Now the next term here, when you see the word ed, it is referring to beta 2. Does my little equation right here have a beta 2 in it? Okay, correct. I don't need any of those. Last one. This is tricky. How many beta 3s do I need? To answer that question, I have to know for what kind of person I want my attitude slope. So if I go back over here to the label, I'm saying if education equals 10. So what goes on the green line here is how many beta 3s I need, which depends on my level of education. So if I want it for 10, 10 is 2 less than 12. What goes on the little line is a -2. So I'm just going to let you stare at that for a minute. Or just stare, you know, it's that point in the class or the afternoon, whichever you're at right now, that's okay. This is why I record. This is one of those topics where I remember taking stats classes or going to workshops and thinking like, oh, I almost had it. Damn it, stop. Like if you just shut up for a minute, I'm really close. And if I had $1 for every time I felt that way, I wouldn't need to do this because I'd be rich. And so if you feel that way, it's okay. You can watch the video and then you can curse at me after class and make me shut up, and then you can work back through this. This is one of those things where it has to like sink. The key to understanding these numbers lies in understanding what they refer to. They refer to this little, stop it, mouse cursor, there, that little equation. That's what those numbers are trying to recreate. And the words refer to the betas, attitudes, and education. The value that goes in here is for the moderator. So Farhan has a question. Did you turn on slopes like we did before in linear combinations depending on this equation? Yes, I think, if I understand your question.
Yeah, I mean, like, depending on whether a slope is in that equation, you give it a 1, or not, you give it a 0. And then finally, you have the interaction there.
Yes, yes. So for the main effects, the reason that education is 0 right here is because beta 2 has nothing to do with the attitude slope. Beta 2 is the education slope all by itself. That's not what we're talking about. We're only talking about the terms in the model that work together to tell me what the attitude slope is. And so for the same reason, the intercept's not relevant, has nothing to do with what the attitude slope is. To get what the attitude slope is, I need whatever it is combined with what modifies it. So the value of the moderator is what goes into the interaction term blank. To demonstrate, let's do another one. This is going to be a 1. So if we're estimating the same slope now for somebody with a higher level of education, let's say a master's degree is 18 years, give or take, I still need 1 beta 1. I still don't need any beta 2s. But now I need a different level of the moderator to plug into my interaction term. Yes, extra credit for Deborah for signing the 6 and the hand signals. Yes. 6. Now let's turn it around. The last 2 are flipping it. So they refer to the second little equation here, which is beta 2 plus beta 3 times a different moderator. So now we're interested in all things education. So do I need the attitude slope by itself if I'm interested in all things education? Nope. Those go to 0. Do I need the education slope if I'm interested in all things education? I need one of them. At a minimum, I need 1. Now the moderator is the other variable. So if I want the education slope for attitudes equals 2, then what goes there? Yeah, -1. Very good. And last but not least, if I wanted the education slope for attitudes equals 5, 2. So the tricky part is what goes here. It's the value of the moderator. That's what goes there. And you know which one's the moderator because it's the one whose main effect is not turned on. And Stata folks, all of this exactly applies the same to you with the change in how you ask for this. The Stata code actually makes it more explicit, exactly what these numbers are referring to. So I actually like that better. Okay, how we doing? It takes practice. It takes practice, but once you see it, it's the magic eye poster. You can't unsee it. So in your formative assessment that I'd like you to try, we'll talk about it on Tuesday. I give you a model, and I'm asking you to write the equations and the estimate or Lincom statements that go with each of the terms. This is what I'm talking about by the equation, and then how would that idea translate into these estimate or Lincom statements. So again, the rules of building simple slopes. Go into the main equation, find all the terms that have that slope in it and bring them down. Factor that variable out and see what's left. That's how it works. FA is due this Monday. Yes, please do it before class on Tuesday. That way we can go over it on Tuesday. And I don't care if you screw it up 17 times, just give it a try. And then you'll get a chance to practice this again in homework 6.
And just one more point of clarification. The entire FA6 is just 3 different practices of the same process with different numbers.
It's one model, and I'm asking for like 3 or 4 different things from the model. The first is what would the predicted outcome be for a particular combination of predictors, and then what would the simple slopes be as a function of the other predictors in the model.
Okay.
All right. Anything else before we adjourn? All right. Thanks for hanging in there. Take care of yourselves. We're almost there. See you next week.